Hello, everyone, and welcome to Talk Nerdy. Today is Monday, June 18th, and I'm your host, Cara Santa Maria. Now, Talk Nerdy isn't always be 100% free to download, and you know that I have a dual model on the show. Basically, I read ads that pays for about half of the expenses of running the show, buying equipment, paying my assistant who helps out with quite a bit, and also paying the editor who keeps the show going. Gosh, I just simply moving over to a model where I utilize the services of the incredible editors at Pro Podcast Solutions has been so helpful, because now that I'm back in school, I do not have the time. But guys, all this stuff gets expensive, and I want to make sure that everybody can always listen to the show for free. That's really important to me. That's never going to change. So like I said, I have a hybrid model. I read ads in the middle of the show, and I also rely on support from listeners like you, just sort of like the public TV or the public radio model. And I use a service called Patreon because I trust them. They're incredible. And it really is a community where you can support lots of content creators. So if you're interested in supporting the show, all you have to do is go to patreon.com/talknerdy, and you can read all about how to do it. So I want to thank the top patrons this week, and they include Rob Schreck right there at the top, supporting the show in the highest tier that I offer. Gosh, Rob, thank you so much. It's just been so incredibly helpful. After that is Phil T-Bear in the next highest tier. You are incredible. Because of you guys, so many people get to listen to the show for free. People who can't afford to give or who probably wouldn't be able to download it otherwise. So I just think that's so amazing. You're giving so many people a really good gift. And also in the next tier, a lot of incredible people. The Zombie Drummer. I know your name because your email's listed, but I'm not going to out you. I love that it's the Zombie Drummer. David J.E. Smith, Jeffrey Perez, Charles Payette, Jonathan Wright, The Honorable Husband, Jafe, Gabriel Felipe Hermio Gonzalez, Brian Holden, and Jeffrey Sewell. I say you guys' names every week, and I know that it's gotten to the point where people tell me they love to hear it. It like lulls them into a nice sense of security before the show. So again, thank you guys so much. And thank you to everybody else who supports. There's a long list of people who support at different levels. I don't have time to read all your names, but just please know that you're really, really appreciated and loved, dare I say. All right, guys, this week it's a really fascinating episode. I talk to the curator of fossil marine mammals at the Smithsonian Institution at the National Museum of Natural History, my favorite museum in the entire country. If you don't spend time at Smithsonian whenever you go to DC, if you get the chance, you don't know what you're missing. You have to go. The air and space is amazing too, don't get me wrong. And the Museum of the Native American. There's so many great museums there, but I do have a special place in my heart for the National Museum of Natural History. And so it's really cool to be able to talk to Dr. Nicholas Pyenson. Or should I say Nick? That's the name that he's using on the book. So he's got a new book out. It's called Spying on Whales, the Past, Present, and Future of Earth's Most Awesome Creatures. So yeah, guys, this is a show all about whales, both extant and extinct. Without any further ado, here he is, Dr. Nick Pyenson. Well, Nick, thank you so much for joining me.
Sure, no problem.
All right. So I am really excited to talk about your book, Spying on Whales, the Past, Present, and Future of Earth's Most Awesome Creatures. And you're using awesome in the real sense of the word.
It's funny because we debated that, how to, there's a lot of decision making that goes into coming up with these subtitles. But, when you think about the ways in which human civilization has interacted with whales, it's a long, deep interaction that goes back thousands of years, and there's a lot of literature. Some of the highlights of English literature have a lot to do with whales. So there's that kind of the big component to it, awe-inspiring, like truly awe, not in the kind of trite way where it's like, yeah, dude, that's awesome. But because that is true too. But, I wanted to evoke the grander component, and also, there's a fun component to doing science too, which is very much part of the book. And there's kind of many things I wanted to do with the book, not just talk about whales, but also how we know about whales. And that is also, consequently, that is a story about how we do science. And that becomes a human story because real people do science. So you want to know the stories about the people and how we figured things out. So
yeah, and that's so important for science communication, for science storytelling, is that, it took us a while to kind of figure that out, but we know that we are people and we are storytelling organisms, and we just connect more with, let's say, non-human animals through telling human stories. It speaks to us more. And of course, this because for several reasons, you're a paleontologist. So that's kind of a weird thing too. Out the gate, you wrote a book about whales, but you study more extinct whales. Not the extant whales. Yes. But whales, in some respects, some of them at least, they're mammals, right? So they're much more modern, but they are sort of, I don't know, I hate the term, but quote unquote living fossils, aren't they?
Yeah. So I think that's a large part. What you're getting at, I think, is the otherworldliness of whales. Mm-hmm. They're so apart from everything else when the very fact that they're mammals, if somebody tells you that, and it's not hard to know that because people have known that since Aristotle, that whales are mammals. They breathe air, they nurse their young, they have blood the way we do.
They knew that since Aristotle? How did they, were they capturing them and dissecting them?
Oh yeah, there's a great book written about what Aristotle knew. We can actually read what Aristotle said, Yeah. But there are more recent kind of reviews of what Aristotle knew. There's a great book written by Armand Leroy that it's called The Lagoon. And it's his journey back to, as best as we can know, the place where Aristotle compiled a lot of his observations that went into his tomes. And whales figure in there. He talks about dolphins, talks about cetaceans.
Cool.
So, Aristotle probably saw the Mediterranean fauna of whales, which includes fin whales and dolphins. So he, for sure, either saw the living ones or certainly the dead ones. And they do look very different from most other mammals. And the reason for that is evolution. There's a deep history to whales. And this is where being a paleontologist comes in. There are things we can know about that history from the fossil record that we wouldn't otherwise know, right? If we didn't have any fossil record, you'd look at whales and every other mammal and you'd say, all right, I can look at their DNA, and it's clear that whales fit in with other hoofed mammals, and specifically the even-toed hoofed ungulates. So deer, pigs, cows, camels, that whole group, whales are firmly ensconced in that family tree. So that's weird.
It's so weird. Totally
So what happens? That tells you that's a big flag for anyone, is that something happened in the past with whales that have made them so different. That first clue, that leads you down the evolutionary story, right? And we're fortunate that we get a fossil record for whales. And over the last 40 years, that fossil record has gotten much better known. From a lot of work that a lot of other people have done, exhuming and excavating and figuring out what the earliest whales look like. And so they tell us this story of transformation, of anatomical transformation. What happens with their limbs? What happens with their vertebral column? What happens with their skull? All these stories that we can read from bones, we can actually know about for early whales. And they tell us about that transition from life on land to life in the sea. And that happens all in about the first 10 million years of whale evolutionary history. And that's cool in itself, because we know that whales, in the bigger scope of vertebrate life, are not unique. That transition has happened many, many times, but we don't always get it in the fossil record. So that's why we hear sometimes, if you open up biology textbooks or evolutionary biology textbooks, whales as a case study of big evolution, of macroevolution. It's because we have the fossil remains of the earliest whales. But it's not just that first 10 million years. It's obviously the full scope of 50 million years of evolution that we get a lot of. We have a lot of their fossils, so we know a lot about what happened. But of course, you don't get everything in the fossil record, so it makes it a lot. There's a detective story aspect to it. And that's one of the things I say in the book, is that it's been useful for me to be a paleontologist studying whales, because it turns out the same kinds of ways that you have to ask questions about the fossil record is similar to how we have to ask questions about how whales are in the modern world. They live remote lives. 99% of their lives are spent under the water's surface because they have to breathe air, but they make their living underwater. So we don't really see them unless we're really clever about how we study them. So I thought there was interesting parallels about how we know, being a paleontologist, to study the deep history of whales and to study them in the present world. And of course, the big question is, whoa. Humans are having a big imprint on the world. And microplastics are basically, as of the last few months, becoming more and more of a topic. It's on the cover of this month's National Geographic magazine. There's a growing awareness of the scale of this problem of byproducts of human civilization. And whales are certainly at threat from not just plastics, but everything else that we do, whether it's entanglement from fishing gear, from modifying their whole habitats. And if you're a cetacean that lives in the freshwater systems in any kind of river, if your habitat gets completely modified, you may go extinct. So
we've seen that happen.
Right. And so the future of whales becomes something really important that we all want to know about. And I think you can only really understand that full scale of what's going to happen to whales if you have an expanded time view. And so that includes not just geologic time, but also historical time, because in the last few hundred years, we've done a lot to change how whales were for many thousands and hundreds of thousands of years, whaling being among the big ones for that.
Oh, yeah, for sure. And I mean, I think there's something that really captures the imagination about whales specifically, like cetaceans in general, but whales specifically, because they're, we talk about charismatic megafauna on land. I mean, we talk about elephants and lions and rhinoceros and all of these creatures that from the time we're littles, these are the animals we recognize, even though they're not in our day to day, because there's something so fascinating and classic about them. But whales are just like on a scale that's hard for us to comprehend. They can be at least massive.
Yeah. So that's the scales of their lives are difficult for us to know. And it's difficult for us to even compare it to, right? So they don't live in cities. We don't see them, like the way we see birds and other mammals. You're likely to see deer and squirrels and cats and dogs, variety of birds just from your daily life. But you really have to happen to live on a coast for any chance to see a whale.
And even still, you're seeing it just like popping up and going back in the water, like so quickly.
You don't really get to know it. And so they're still very remote. And I think for scientists, we like to pull back on the unknown by observation, right? You want to actually see what you're studying. That's really hard with whales. But the most exciting thing I think about being a scientist right now is that we all live on a massively instrumented planet. Everybody's walking around with a supercomputer in their back pocket. And we also have cell phones with cameras. So people are recording video of any kind of interactions with whales, whether it's a dead carcass, a carcass stranded on beach, or they're on a whale watch, or you can send up a drone. There's actually not that much legal barrier for somebody on a whale watch to send up a drone and take pictures in a way that we could never get. I mean, I see these drone videos and it's astonishing because I just see it on Facebook scrolling through and it's like drone video. And you're seeing natural history that literally people have tried to guess about, but not actually documented until now. Using drones is much more complex for scientists because of the legal permitting involved. So it's not as easy as just, hey, I have my, DJI and I'm on a boat and I'm going to throw it up. There's a lot for a lot of the infrastructure of doing science. You need to do it right. But regardless of the way that you collect this information, so whether it's drone or a removable tag, this whole approach of biologging, of attaching an instrument to the animal itself, removable or permanent in some cases, that is another way to know them. So we are living in this golden age of being able to know about these animals, and that's giving us insight into the scale of their lives. So how big they are, how they're able to maintain that large body size, where they go when we don't see them, and how long they live. I mean, these are all facts that are, when you really start to grapple with it, are amazing. And that goes back to the awesomeness of whales. We want to know more. And so knowing is if you're a scientist, that's the way you want to know about it. And that's how we get at these facts. And I think how we figure it out is that's a great example of how science works.
Yeah. And of course we, like you said, we're living in this instrumented world. So now more than ever, we have kind of the excitement and the challenges of big data, and scientists are able to look at all of the data that they themselves are collecting, but also the citizen science data that, everyday people are collecting, right, and helping to sort and helping to examine. But you are in this really special kind of position because you are able to look at sort of it's funny that paleontology has never been called forensic biological history, because in a way that's really what it is. But somehow the word forensic never made itself into that vocabulary. Yeah. But so you're at the Smithsonian Museum of Natural History in Washington, D.C., which I have to say is the best museum in the country.
Oh, that's too much. Favorite museum. I wouldn't agree with you, but yeah, sure.
No, it absolutely is. I go to museums a lot. I'm a huge museum nerd. And every time I'm in DC, I make sure to add an extra day at the top or the end of my trip so that I can just spend the day at the Museum of Natural History. Air and space is cool. A lot of people love air and space. I like to pop in periodically. I love to go to, there's a lot of different museums that I love to visit, but natural history, just for people who don't spend any time in DC, what they probably don't realize is that you really can't see it in a day. It's just too big and it's just too wonderful.
You'll be even more excited to come back to the museum next year when we open our fossil hall, our new deep time renovation to all the dinosaurs, all the fossil marine mammals, everything. That's about a quarter of our museum exhibit space that's been offline for several years. And
I'm so excited.
Super neat. I mean, there's fossil whales will feature in them. And a lot of the stories in the book are actually going to be featured in the new fossil hall. So there's a real connection to all this stuff.
So you don't know this about me, because why would you? But I studied neuroscience and I'm studying psychology now. And, I've been a big science nerd for a long time, but my office, I'm looking at it right now. I have the entire Carnegie collection of dinosaur awesome. Toys. These scale model dinosaurs.
They're great.
Yeah, you're a paleontologist. You know this.
Yeah.
I have a lot of paleo nerdy stuff. I've got fossils that I've collected myself, visiting Morocco, visiting Texas. And I'm really into, and I actually have a lot of marine fossils, which is quite common in Texas because a fair amount of Texas used to be underwater. Yeah. And so I would love to talk a little bit about how we know what we know about these ancient whales. A, how different are they from modern whales? B, you mentioned, I'm getting so excited. I'm going to ask you 1,000 questions at once. You mentioned 50 million, the number 50 million years. Is that about was it 50 million years ago when we can pretty confidently say that's a whale versus that's a whale-like ancestor?
Good question. So how do we know about, what makes a whale, and how do we know for anything that doesn't, when we find bones of a 50 million year old whale, how can we say that? So there's actually a longer story to be told about all the ways that we've discovered earliest whales that live from around this time period. The first, I think, a good scene setting context is that the continents haven't always, you know this, but just for listeners, the continents haven't always been where they are today. And sea levels changed and the configurations of the continents have changed. 50 million years ago, there was a broad equatorial sea called the Tethys Sea that stretched from where Spain is today all the way through where the Mediterranean still is, but on through Jordan, through Iran, all the way to Afghanistan, Pakistan. India had not yet collided with South Asia. And so there was an open, India was actually just on the verge of doing that. And it was part of a big island archipelago, as best as we can tell.
And so I have to ask just because I was recently in Morocco and I was there to study meteorites, but I got really fascinated by all the fossils that are there. And they're mostly, I actually bought a really beautiful Orthoceras fossil while I was there and brought it home, which is an ancient squid. Was Morocco in that sea? North Africa was underneath that sea?
What makes that a little more complicated is the ocean current systems. So it is likely Northwest Africa was part of a current system. And so you're probably looking at the phosphate deposits. There's a very, very rich record of
Okay.
from Morocco, from Cretaceous, and then on through after the extinction of non-avian dinosaurs into the times of early whales. And we do get early whale fossils from places in Morocco. It's the borderlands of the Tethys Sea, but it's where it's open to the Atlantic. And we get the mixture of current systems. And, you know, you can imagine how different ocean current systems are when the continents aren't in their current configuration. So,
we could probably only begin to try to model what the oceans actually moved like.
That's the job of paleoceanographers, and that's
a job. That's so cool.
And so it's important for industries like the oil industry. If you want to be able to recover petroleum, you need to know where these deposits are, and that is definitely dictated by ancient productivity, ancient ocean current systems, ancient temperatures. The whole ways in that we can know ancient Earth systems is knowable directly through the fossil record. So again, all these different flavors of paleontologists have to be clever and use detective work, the tools of inference, to understand what past worlds were like. And going back to whales, so the oldest whales we know of are from about 50 million year old deposits from India and Pakistan. They're unfortunately from some places where we can't go because of geopolitics. There's not much prospecting in the Baluchistan hills today because of human conflict, right? That's not.
But there was historically,
up until a few decades ago, there were a lot of people who were prospecting, and so they would find these fossils of the earliest whales. And the way that we know that they're early whales has to do with features on their skulls, on their cranium, specifically with their ear bones. So they have ear bones that look unlike any other mammals except for living whales. There's key features. And in the book, I talk about this exactly.
And when you say ear bones, do you mean like the inner bones of the inner ear or exterior?
Yes.
Oh, okay.
So it's features of the inner ear and also the middle ear. It's not so much. So outer ear bones, whales, in a point in their evolutionary history, start to decouple those from the rest of their cranium and become acoustically isolated from the rest of the skull. So when we go underwater, you know, if you go swimming, you can hear sound, but you generally have a hard time figuring out the direction of that sound. You don't really know where splashing is coming from. Whales don't have this problem. And that's because for the last about 40 million years, they've had acoustically isolated ears. So they can hear where sound is coming. And obviously, you can imagine what a great trait that is that could confer an advantage. And what's really interesting, this goes back to like the many iterations of life going from living vertebrates from going on land to the sea. Sea cows are this way too. They have acoustically isolated ear bones.
Manatees.
So dugongs and manatees have very parallel sets of aquatic adaptations.
Wait, what's the first word you said?
Parallels. They do. Yeah, no, they do.
No, you said something and manatees.
Sea cows, dugongs and manatees.
Dugongs. Yeah, so what's a dugong?
A dugong is a special flavor of sea cow that lives in the Arabian Sea and in Australia and waters off Australia. They look like a manatee, except they have a forked tail. So they have a tail more like a dolphin. Manatees have like tails, and their snouts are shaped differently. They actually have tusks that barely emerge out from their muzzle, and manatees have toenails on their flippers, which is totally cool. I mean, you've never, if you want a better example of evolutionary history, just look at a manatee flipper, you know, and they look like what would happen if you squished an elephant's foot.
Oh my gosh, manatees are pretty weird now that you're mentioning that.
And what's cool is that manatees and dugongs together, they have a 50 million year history, just like whales do. But they're clearly, they've had a differential success, right? Like we don't have 80 species of manatees and dugongs on the planet the way we do with whales. And I think that their differential success can be attributed to the fact that one's a herbivore and the other one's a carnivore. Whales evolved the ability to eat fish and squid and krill. And so they had access to resources that weren't just limited to the coasts the way that Sirenians are. Sea cows have always had to be herbivorous. They didn't have that added ecological need.
Yeah, so not only does that give them less options, fewer options, so they're restricted to certain areas, but it also means that they have to, I'm assuming, eat a hell of a lot more food to get the same nutrition.
So this is what's really cool about studying whales. When you start examining these just basic facts of their ecology, you very quickly get at big questions about whole disciplines. So this is now a discussion about the physiology of whales. How do we know how much they eat? Well, that could be a question you might be able to answer from putting a grad student on a Zodiac and binoculars and, have them kind of come up with some metric for measuring consumption. Or you could get at it from gut contents, or you might do an echo sounding of the available prey patches from krill and other fish that are in the water. I mean, so all these ways that we'd want to be able to answer that question. I mean, it seems like it would be pretty easy. You'd say, well, I'd expect a fully carnivorous mammal to have an elevated metabolic need versus a sea cow. Well, that's cool, but how are you going to actually put numbers on that? And so that's the challenge of being a scientist asking a question, any kind of scientific question about whales, is that to really get at numbers, to get at data, you have to be clever, or you have to be really tenacious about the ways in which you get those data. And that's what's been really interesting for me in the course of my career, is trying to think about all the different ways we can figure out some of these questions. And that can be from anatomical literature that's very old. Some observations are only known through, reports that people made in anatomical descriptions that are 150, 200 years old. There's tabulations in the whaling literature of length and width and girth of some whales, but not all of them. There's a lot of tallies of the number of whales killed. And so that's kind of, you can think of 20th century whaling when over 2 to 3 million whales were killed.
Jeez.
But that's like a biodiversity inventory of the world's oceans circa 1900 through 1960, right? And that's a special set of data we will never get again. And these are all different kinds of data that you have to creatively use to answer these questions, because in some cases, that's the best we're going to get. Again, it goes back to being a detective, I think, and trying to think about how to answer these questions, either by inference. For the most part, you're not going to be able to do an experiment with whales. They're not like zebrafish. They're not like C. elegans. You can't keep them in a lab and run them over several generations or manipulate their genomes. It's a lot of inference, and like I said, detective work is the primary basis for knowing about them. And at least in my experience, that's been a lot of fun. And that's a very human story about trying to figure out these animals.
So I have to ask you some probably like seemingly naive questions, because I'm realizing as I'm talking to you that I know very little about mammalian sea life. So I generally think of, we mentioned manatees, we mentioned dolphins previously, and we know that there's some freshwater dolphins and some, obviously, we all know that there's dolphins that live in the ocean. Are dolphins whales? Like what, I know that I've used the word cetacean a lot. Where are the dividing lines? Like, I just kind of have always lumped all the mammals that live in the sea together, like walruses and seals, but they're different in their kind of distinctions, right? In their taxonomy.
Right. So we'll get to whales in a second, but first, all marine mammals are mostly unrelated to each other.
Really?
So sea cows are very distantly related to whales. And both of those groups are distantly related to seals and sea lions and walruses. So this means that there were multiple occasions historically where these animals went back into the ocean? Exactly. That is the big picture fact about marine mammals, is that they went back to the ocean many times in probably different places. And the consequences of those reinvasions of the water, because they all ultimately have ancestors like we do that go back to Tiktaalik. The early fish to go back on, Tiktaalik is part of that lineage of fishopods, of fish that have limbs.
Fishopods.
Neil Shubin wrote about this really well in Your Inner Fish. And that's...
Yeah, so I was going to say, anybody who's listening right now and remembers when Neil Shubin was on the show, I had him on twice, and he talked about Tiktaalik quite a bit, this like early tetrapod. Sort of like Tiktaalik really was the ancestor to us all, if we're talking about organisms that... are, tetrapods, meaning that they have four legs, right?
Exactly. So tetrapods have gone back to the water from land ancestors many, many times. And for marine mammals, you're looking at the mammal version of that story. But
Okay.
Go back to your Carnegie collection on your desk. If you have a mosasaur or a plesiosaur or any kind of early sea turtle, reptiles did that too during the Mesozoic, during the age of the dinosaurs.
Oh, right, because they're not fish.
Right. So marine reptiles have this whole series of invasions over about 150 million years as well. And this is what's super cool, right? If you look at a mosasaur, that body plan looks broadly like the body plan of the earliest aquatic whales. They have flipper-shaped forelimbs. They have reduced hind limbs. They have a long vertebral column where the pelvic girdle is dissociated from the vertebral column, so that allows for whole backbone flexion and undulation. Yeah. They have skulls that look remarkably similar. And it's not just...
Yeah, just to like the naked eye, like just ostensibly mosasaurs. And for anybody who remembers like Jurassic World, there was a giant, I mean, it was like too big. Like there's never... Yeah, apparently like mosasaurs weren't that big, but that giant mosasaur that like jumps up and is like rawr and eats stuff, like it's super whale-like.
So, and that's true whether we're looking at ichthyosaurs and dolphins. So a lot of people say that ichthyosaurs are very dolphin-like. They have
because they have that drawn-out kind of nose.
Yeah, they have a long, pointy nose. They have a dorsal fin in outline, and we know that because many ichthyosaurs are extremely well preserved in the Holtzmaden shales. So we get skin outline impressions. And they basically look like the reptile version of a dolphin. But the way I think about it is, no, ichthyosaurs were first, and then dolphins evolved some 160 million years later. So
of course there are these ecological niches that the evolution was shaping, nature was shaping, and they found similar plans along the way.
That tells you about how evolution works. That's what's really cool when you see that scale of convergence across very different branches of vertebrate life. That's telling you that selection is operating the same way for those groups. And here's the big question, and we don't even have the answer for it. This is a great graduate level question, which is, are the rates of evolution the same? Are they different for reptiles than they are for mammals? How long does it take to evolve a mosasaur-like body plan versus, if you're a reptile, versus the ways that whales have done? Nobody.
That's super interesting.
That you could answer with the fossil record, and only with the fossil record, right? Like this is the kinds of questions that paleontologists want to ask when you have this arranged over time.
I have a question for you. Random question. Why are there no extant, I mean, not why, but have there ever been any parallels? We're drawing these parallels, at least in terms of the niche or the niche between an ichthyosaur and a dolphin. Of course, two totally different creatures. One is a reptile, one is a mammal. And we drew this parallel between the mosasaur and the whale. But there's this whole other chunk of paleontological sea creatures, the plesiosaurs, that are super weird. And we don't have any extant, similar. I mean, people like to think that Loch Ness Monster exists, but it doesn't. And so, is there anything alive today or at least somewhat recently that kind of fit that body plan? Or is that just maybe not a successful evolutionary kind of option?
I think a plesiosaur paleontologist would say plesiosaurs are actually wickedly successful. They just aren't alive today, right? Like if your definition of success is what's alive today, that's a very narrow, that's a narrow part of 99% of everything that ever evolved in the history of life. And so, I think paleontologists are more comfortable saying how long did it last? And mammals, there's the oldest mammal lineage, the longest surviving, whales and sea cows among the marine mammals have been around for 50 million years. Sea otters, maybe a million years, sea lions. So sea lions, seals, and walruses all fit together. They all hang together. They're no more than about 23 million years old. And you look at that versus, say, ichthyosaurs, which were around for well over 100 million years. Now, what's interesting, yes, there are some things that we don't see today. There's not really plesiosaurs. But then again, there's nothing really like a walrus in the fossil record.
There's not. Oh, interesting.
So there's occasionally these things that evolve that without counterparts. And that's the only, then it becomes really interesting. You want to ask, is that some kind of, like you said, is that some kind of special way of life that only evolved in a certain circumstance? And that's what makes looking at the fossil record so much fun, is that you never know when somebody's going to find something without parallel or with, that's the convergent version of this and that. It's a lot of fun to kind of play these games, but you always want to be able
because
to,
every fossil is an intermediate fossil, right?
Yeah.
Like the creationist argument of like it's total garbage, because every single time we find a fossil, it is some branch of this crazy twisting, branching tree. And it's, it's probably a dead end. They were all dead ends. We're dead ends. That's not how evolution works. But it fits somewhere in this natural history as we find things. And sometimes they can tell us about things that are extant because they are similar to what we might have thought of as a precursor to what's alive today. But for the most part, none of those things actually were clear precursors, right? Like they were their own organisms. And that's an important distinction to make.
So this is the whole, we inherited the way of thinking about the biological world from Darwin, who was the first one to say, you know what? The whole biological world has a history. I mean, even the whole universe has a history, right? So once you acknowledge historical thinking, then you know that, at least for life, there is a tree of life. Things are all related to each other. And if you acknowledge that and accept that, then we can start to ask questions about how things have changed through time and what our evidence for that change is. And that can be evidence from DNA. That's one way of looking at things. From the fossil record. You can look at how the environments have changed through time, too, as a way to guide these questions. And they're all pieces of evidence that help you with that detective story. So for whales, if we went back, I talk about this in the book, if you go back to the Eocene, about 50 million years ago or so, and you were able to somehow see an Eocene beach party with all these early whales hanging out, you wouldn't be able to say which whale is going to be the one that goes on to success in the future. You just can't make that prediction from what you see in the past because of all the millions of random things that have happened that have allowed some lineages to survive and others not to. There is no mass extinction event in marine mammal history. So it's not like with when you're looking with other groups like turtles or birds. They all have ancestries that go through a major mass extinction event, the last one at the end of the Cretaceous. And that's a hard barrier. And we know some lineages in these groups did not make it through and others did. But with marine mammals, we don't have that kind of convenient hard marker. So we have to look, so the ways in which we think about these early whales, we almost have to imagine them without respect to the whales that they've become today. And I haven't forgotten about your original question, which is like, I just call some things dolphins, other things whales. So I call them all whales, like whether they're porpoises or dolphins or the really big whales. The words we use, so you can look at the common names that we use for today's cetaceans. And we tend to use whale for something big and something else for when it gets smaller, like a dolphin or a porpoise.
Although we do call orcas killer whales, and they're more like dolphins, so that is confusing.
Right. So the names we use, the common names, are not good guides for phylogeny. They don't tell us about their evolutionary history. They're just convenient or historical happenstance. So I call them all whales, and then there's two main big groups today. There's the baleen whales. So you can kind of split the groups up by opening up their mouth and looking inside. And I talk about this in the book. Just look inside the mouth of a whale. And if it's got baleen plates hanging from it, those are the filter-feeding baleen whales. If it doesn't and it has teeth, although some of the toothed whales don't have teeth, there's some suction.
But they also don't have baleen.
They don't have baleen. So it's really baleen, yes or no. For the modern world, if you did this with fossils, that's not really, you need to have more anatomical expertise. But that's a convenient way to know which house of the great whale family group modern cetaceans fit into. Baleen whales on the one hand or toothed whales on the other. And they also sort out conveniently by their ecological mode. The baleen whales have baleen because they filter feed. The toothed whales don't have baleen, but echolocate. So they use biosonar instead, which is kind of this...
Because they have to actually find food and then chew it up.
Well, so all whales have to find food, and that is a big mystery. But toothed whales, the echolocating ones, hunt individual prey items. They're pulling down a single fish or a single squid, sometimes a giant squid if you're a sperm whale. But baleen whales...
But the baleen whales just swim and get krill or plankton, and it just kind of comes into their mouth.
So they're going after a large aggregate of prey, and that's a different strategy because it's usually much smaller prey, but you're kind of taking a bigger chunk out of many of those swarms hanging out together. So I always like to think about baleen whales as kind of taking a bite out of a superorganism. And you see that really well when you see like any of this BBC or PBS footage of whales swimming underwater and feeding on a bait ball, these big, huge swarming, big ball of fish, or sometimes it's krill, but we don't really have good video of that from underwater. But in all cases, that swarm behavior, that group behavior almost makes it like a superorganism, right? And whales, even though they're massive, are still not as massive as those prey aggregations. And they're just taking bites out of it. And to process it, to sort out prey from water, you need some kind of filter. And that's what baleen whales have. And there's a whole story about that I talk about in the book, which is this amazing anatomical trait that baleen whales have and how it evolved. And this is the cool thing about studying whales, is that they really are like mammals from space. They're so different, and you just start scratching at any aspect of their biology, and you quickly discover that there's so much more to know about. There's so many mysteries, just alone with baleen whales and toothed whales. Well, how did filter feeding evolve? How did echolocation evolve? How could we know? What about the fossil record? You just immediately start diving deep into these questions.
Which one's newer?
Well, so they share a common ancestor. And as best we know, there's some new fossils that came out in the past year. And so this is a very hot field for paleontologists. We actually have some new discoveries that are going to come out, hopefully by the end of the year, maybe by the summer, that will weigh in on this question about where filter feeding evolved. But the oldest baleen whales, so these are baleen whales that did not have baleen. This is part of the problem about talking about.
So this is like, starting the process of filter feeding before they had really good anatomical structures to do it.
So this is, again, the challenge of using common words to describe organisms, is if you go back farther enough in time, think about the feathered dinosaurs. So when we found feathered dinosaurs, and we, technically Archaeopteryx is a feathered dinosaur. So we've known about feathered dinosaurs for a long time.
I call Archaeopteryx a dinosaur too. Thank you very much. And I have Archaeopteryx, the Berlin specimen, tattooed on my forearm. It's like my favorite. Yeah, it's my favorite tattoo. But I know that a lot of paleontologists call it a bird because it's like it's a bird-like dinosaur like bird.
Right.
Like
so
there's
the
whatever.
Words we use to describe these animals quickly fail when you start getting deep enough in their history. And the same thing is true with baleen whales. So because we call them baleen whales, you think they must have baleen, but at a certain point in their evolutionary history, they didn't. And so we go back far enough. So some new fossil discoveries in the past year have pinned back that the oldest baleen whale, it didn't have baleen, it had teeth, to about 36 million years ago. And that is wickedly old. That is crazy old for someone like me, because you just don't, what that means is that there was a time period about 35 million years ago when we have the earliest baleen whales. We must have also had the first echolocating whales, even though we don't have a record of them, and the last surviving members of the early whales, all living together. So the late Eocene was probably a very strange time if you were a whale biologist, because you'd go out on a whale watch and you'd see just all these different kinds of early whales. And again, think about it, you wouldn't know which ones would become blue whales and which ones would become bottlenose dolphins and which ones would go extinct. And that's kind of the, paleontologists almost play the science fiction game of imagine what it was like back at this time when you couldn't have really known what the futures were like for these groups.
It would have also been a weird time to be a whale biologist because there were no humans.
Well, in my time travel, in my construct, you definitely, you got your spacesuit and you can investigate all these things and not have a butterfly effect. You're not altering the future. So
all those things.
It's all, come on. I think.
All right, guys, let's take a quick moment to thank the sponsors of this week's episode, starting with Blue Apron. Blue Apron's offering you, the Talk Nerdy listeners, your first 3 meals for free. So when it comes to dinner, why not let Blue Apron take care of the planning, the shopping, and everything except the cooking and eating. And there are some amazing meals coming up on the menu, like spinach, tomato, and goat cheese quiche. Oh my gosh. Summer vegetable gnocchi. And hey, if you're a meat lover, what about some Ooh, gosh, there's so many to choose from. Sweet chili beef and vegetable stir fry, or maybe, oh, yum, 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 spiced chicken breasts and mashed potatoes. Guys, it's super easy. It's super convenient. You have a ton of variety. You get to choose which recipes you like. There are 12 new ones every week. The food is super high quality. And for me, what I love the most is that I don't have to think about it. Like, I'm not creative in the kitchen. I actually hate cooking. I'm not very good at it. But with Blue Apron, they send you everything you need. It's perfectly portioned. It's really, really fresh. And you get these really easy to follow recipe cards that have all the ingredients on them and step-by-step instructions, so you really can't screw it up. And you end up making things you'd probably never choose to make on your own. Like, when's the last time that you thought to make, I don't know, honey ginger pork chops or sweet potato and spicy cucumber bao buns in your kitchen? Spiced chickpea and vegetable tagine. Like, oh man, I want some tagine. That sounds so good. So I don't know what you're waiting for. If you haven't tried it yet, I've been telling you about it for a while. I think now's the time. Check out this week's menu. Get your first 3 meals for free at blueapron.com/nerdy. Again, that's blueapron.com/nerdy. Ready to become a leader? Enroll in Army ROTC. You could get a full tuition scholarship, and you'll graduate a leader and an officer in the U.S. Army. Army officers inspire strength in others. To receive more information about the Army ROTC program, visit goarmy.com/podcast today. Paid for by the United States Army. All right, guys, let's get back to the show.
Going back to whales, so I call them all whales out of convenience. Some of the smaller ones are dolphins and porpoises, and they all hang together as echolocating.
But specifically, those are all cetaceans.
Yes, so cetacean is a good term to use for all of them. In the book towards the back, there's a section called A Family Tree of Whales, and I kind of go into all this, like, how should we talk about whales? And cetaceans is a very good way to talk about them all. So when I say all whales are just whales, yes, cetaceans is a very good term to use as a substitution for that. And that's actually a more robust way, because you'll never be wrong for saying that.
So, okay, what about things like, what's a narwhal? That's a weird animal.
So narwhal, open its mouth. It won't have teeth, but it does have a giant tusk. And that's a elaborate canine tooth coming out of its snout. Mm-hmm. So that is a toothed whale. It's an echolocating whale. Narwhals are... Oh,
it is a whale. Oh, cool.
Yeah, it's more closely related to belugas. And so that fits into... Okay. So belugas, narwhals, killer whales, dolphins, porpoises, they all fit into the oceanic dolphin group. They're all closely related. They're all more closely related to one another than any of them are to, say, a river dolphin or a sperm whale. Mm-hmm. They all hang together. And so narwhals are freaky because they have a canine that is as long as its entire body length, right? These tusks, they spiral. And here's the really cool thing. If you come to the Smithsonian, and we have a narwhal skull already on display in the Ocean Hall, in the Sant Ocean Hall. Okay. We also have a narwhal exhibit right now. It's a small temporary exhibit, but it's all about narwhals.
Oh, really? Yeah. Oh, cool.
And it goes through traditional ecological knowledge. It's great because obviously there are people who live in the Arctic who still rely on narwhals for food. First Nations, indigenous peoples, they hunt narwhals, and it's an important part of their culture in literally sustenance. So, so there's, from a natural history standpoint, narwhals are just fascinating in their own right. But if you look at that skull in the Sant Ocean Hall, we have a 2-tusked narwhal. And this is the... What? So we think of narwhals as just having one tusk, but vertebrate animals are bilaterally symmetric. And so there are narwhals that occasionally are found and that live that have 2 tusks. And actually that's because we have bilateral symmetry because both those tusks grow. The whole reason for having a tusk has been the subject of a lot of discussion. And I think the best way to think about it is kind of like a peacock's tail. It's clearly a trait that's under massive sexual selection. So they don't hunt with them or anything like that? Well, so this is the question is, how do they use them in the wild? And it goes back to the challenges of knowing about cetaceans. We only see them at the water surface. And if we're lucky, we can throw a drone up into the sky and maybe see a little deeper into the water and what they do. But we're just now beginning to know a little bit more about what narwhals do with their tusks. And it's really not clear to me, at least, they use tusks for hunting. It's a serious investment biologically because it's a mineralized structure. Just a side note, those two tusks. So what I was going to get at is that the tusk is very long, but it's also spiral. It's a spiral shaped structure that twists. And here's the crazy thing. You'd think that a bilaterally symmetric animal would spiral in a mirrored way, right? For left and right sides.
Like one would twist to the right and one would twist to the left.
That is not the case with narwhals. Narwhals
that's weird.
both have sinistrally rotating. They both have sinistral tusks, whether the tusks are on the left or right side. And that's weird. Totally weird. And why that is, nobody knows. So
that seems like a mutation to me.
Well, but so why is that? And there's a lot of other examples of asymmetry in whales, actually. And in the book, I talk about, we're talking about convergent evolutionary convergence. There is a species of whale that evolved a walrus-like face that lived off the coast of South America 5 million years ago. And it's called Odobenecetops. And we call them informally the walrus whales because they're basically dolphins that evolved a walrus-like face and tusks. But their tusks don't look anything like narwhal tusks. They're even a different tooth. And they're straight. They look more like walrus tusks than they do look like narwhal tusks. So the mysteries of whale evolution are just compounded when you really start looking at how much we know, and there's always more questions than we have answers to.
I'm literally just like scrolling through pictures of narwhals right now, Google images, and like I'm really understanding your use of the word "awesome" in the subtitle of your book. I mean, they're just I just found a double-tusked one.
Yeah.
They're just the weirdest looking animals.
So they're not even, you can pick any group of whales and just find how freaky they are. Mammals from space is really how I think about them.
It's so funny too, because when you mentioned that, I didn't want to interrupt, but I feel like it's a sad state of affairs when we have to put an asterisk there because of this recent panspermia article about cephalopods being from space. Yeah. They're not actually from space.
I want to make that clear. They're not really from space. I just mean that as a form of rhetoric, as a turn of phrase. They're not actually from And that's, that again is like evolution is true. We know that things have a history, and that's our best explanation, best scientific explanation for where they came from. And it's amazing how much we actually don't know about most of the multi-ton mammals that live in the world's oceans and rivers. I mean, it's almost like dinosaurs didn't go extinct. Imagine a world, again, we're going to play a little sci-fi game. Imagine that dinosaurs survived the end of the Cretaceous and it's Jurassic World everywhere. That's kind of what the oceans are like with whales. Like we don't know how many species of whales there are in the world's oceans.
How many have we named now?
So so how many have we named versus how many are valid species is definitely a debate among scientists. Okay. But I think an acceptable number is 80 species. And what's amazing is that many species have been described in the 21st century. So we are still describing and naming species of whales that are alive in the world's oceans that we didn't recognize any time before now. And so that tells us that the age of discovery for whales is ongoing. It's not like we've described everything that's out there and we're done. We really don't. You can pick any group of whales and say, how much do we really know? The second most species-rich group of whales, of cetaceans, is a family of whales known as beaked whales. And you may not have heard much about them. You can Google beaked whales, and I encourage you to do that and pull up an image. It kind of looks like a bottlenose dolphin that's been extended to the scale of a submarine, and they're freaky, freaky animals. I remember the first time I heard about them and I Googled them and saw an image, and I was like, no way. There's a whale that looks like that? Well, it's not just
doing
one.
That right now.
There's over 20 species of beaked whales. There's actually more species of beaked whales out there that we haven't yet identified. They're cryptic species because their taxonomic identity isn't something easily observed. But we do know from molecular...
They look a lot like dolphins. They're toothed
whales, but they dive deeper than any other species of whale. And there's 20 different species. And here's the thing. We know nothing about most of those 20 species. At best, 4 of them we've actually whaled in some cases or have been documented from strandings or we've put tags on. But even there, we know significantly less about them than we do about, say, sperm whales or humpback whales or killer whales.
The vast majority of these images, actually, when you do a Google image search, are either illustrations or beachings.
So the ways in which we know about beaked whales, for the most part, is from stranded animals, carcasses, or in many cases, a single skull, like a beach cast skull that's in a museum collection. That is what an entire species rests upon. And that's a living species. Otherwise, we don't know what it looks like. We don't know how deep it dives. We don't know how it reproduces. All those facts that you just imagine are known about most mammals, we don't know.
It's just like modern paleontology.
That's what I mean. Yep.
Wow.
So that's why, it goes back to kind of the reason why you trust a paleontologist to tell you about whales, because I think that the challenges of knowing about them are very similar to the challenges that you encounter as a paleontologist. And the other thing I think about that too is that the expanded timescales that you have to think about them are really important now because the Earth is changing at geologic scales and rates in human lifetimes, right? The recent reports of a summer-free or sea ice-free summer in the Arctic, that's going to be a reality for my kids before they graduate high school. It's pretty clear where that's heading. And that's just a linear extrapolation, right? Like we know that complex systems react in nonlinear ways. And I don't think it's a crazy thing to imagine that by the 2030s, there's no sea ice in the Arctic. And so what that means is that the Arctic Ocean is a true ocean. It's more pelagic than it is frozen. And that's, what that means for whales or any other organism is not necessarily good or bad, right? Like it's happening, it's changing. And for whales, for most species of whales, that means the ones that live in the Arctic probably are going to get more prey resources, more sustained throughout the summers, right? More sunlight, less covered ice, more biological productivity, more food. But with no ice, that's going to become a shipping lane. And so the chances for human threats become multiplied from oil spills, from ship strikes, from, just the detritus from human civilization. We already know there's tons of plastic in the Arctic. The most remote places on the planet still bear the signs of human effects, microplastics.
Yeah, they found a plastic bag in the Mariana Trench.
Right. So there's no place on Earth that isn't impacted or has some kind of part of the signature of human civilization. And so I think the question is not, so we know the planet is changing. It's changing very rapidly at the poles, much faster than it is for the rest of the world. I think the questions are, what does this mean for all the other organisms that we share both resources and that we need to survive on the planet?
Yeah, see, that's the thing. There's something about them, and they're not all big, right? A lot of whales are smaller, but they're still big in the grand scheme of things. Yes. And there's something about a really, really big animal, especially when we're talking about like a blue whale or something, the biggest animal we have on the planet, that when you think about climate change, or you think about acidification of the ocean, or you think about, like you said, a release of a certain amount of gas or mineral or certain organisms being released that were bound up previously, when it happens really fast, like just faster than geologic history has shown before, that they just might not be able to adapt fast enough.
That is the question. So how is any lineage able to evolve at the speed at which the environment is changing? And that's a question for coral reef biologists as much as it is for whale scientists.
And it's looking bleak for the coral reefs, isn't it?
It doesn't look so good, but there are some corals that are evolving, to live in these new conditions. And that's the thing, is that global climate change is not a one-size-fits-all kind of effect. I mean, it's going to be different in different places in different parts of the world. Sea level rise is going to be different in different parts of the world. It's still going to rise, as far as we can tell. And that's, I think what we see happening today is a legacy of buildup over the last 150 years. And that's one of the fascinating things about some species of whales. They have lived through the entire industrial revolution. They've actually lived through the entire rise and fall of whaling. So that's one of the reasons I describe bowhead whales as time machines. There are bowhead whales alive right now that probably were born during the time of Thomas Jefferson. That is
That's crazy.
Well, but that's what the data show us about how long some of these species live. And
so what is the longest lived whale?
So the best data we have about that is from two sources of data. One is from the fact that we find 19th century whaling implements in the backs of whales that are harpooned in the 21st century. So clearly bowheads are able to live at least 100 years, probably more, 130. And what's really cool is that number, the best when we, I describe a lot of this in the book. There's a whole chapter about bowhead whales and how we know this. So there's the 19th century whaling implements. That's a little bit of time travel right there. And it also tells you that the animal had to have been fairly mature when it was struck but not killed by that whaling harpoon. Yeah. The other source of data come from amino acids in the eyeballs, and there's a specific ratio of left-handed to right-handed chemical structures of these proteins in the eyeball that have remained that way since the animal was in the womb, because there's no the rate of decay and the relationship of those two right-hand and left-hand structures follows a specific ratio up until the animal dies. And it's only because that we can get the eyeballs of freshly dead bowheads from the Arctic because they're whaled, because the United States is still a whaling nation. And that's something that a lot of people forget just because whaling happens above the 49th parallel. So we're able to harvest these eyeballs and extract and get a number on where that ratio is at and apply it to the curve for the left-hand versus right-hand structures. And that number that we get from plotting on the curve, in some cases, it's exactly the kind of number that we'd expect given those data about 130-year-old bowhead whales. And the highest number that we get for some of these animals, there's another way we can know too, which is also from counting the corpus alba from the number of pregnancy scars that female bowhead whales will have. So you can actually count how many pregnancies, and based on the interval between pregnancies, you can kind of predict how old that individual whale must have been. We all get either so you have like three different ways that you can know bowhead whales. All those ways point to bowhead whales living certainly more than 100 years. And in some cases, because we've hunted so many, you get the number 200 years. And that seems like such a crazy number. But if you only had one line of evidence, you'd say that's crazy. But the fact that you have multiple lines of evidence pointing to that fact tells you that that's not a fictitious number. That's a reality. So then, think about what that means in terms of the scope of what we have done to their habitat in 200 years. So that means a bowhead whale born in the 19th century has seen the rise of fossil fuel use. So that's a change in the carbon ratios in their environment. It's seen the turnover from sailing ships to diesel-powered ships to nuclear-powered submarines to the widespread pollutants in their environment, to sonic changes. So we're using sonar, military sonar for oil. There's a lot of acoustics that are used in oil exploration that we know harm marine life. And that's all used in the habitat that bowhead whales live in. So,
and of course, plastic.
And plastic
which didn't exist before the middle of the last century.
Exactly.
So not only do they have a new chemical signature in the ocean that they never evolved to deal with, they have, like you said, like pollution of like sensory pollution, light pollution, sound pollution, things like that.
Right. So a bowhead whale born today in the Arctic is going to, if it lives 200 years, imagine what kind of Arctic it will see. It's going to be an Arctic completely unlike any of the habitats that all of its ancestors lived in.
If it can survive it.
Right. I mean, that's the big question. So, and bowhead whales are very closely related to right whales, and we're very concerned about right whales because not only have they not recovered from Yankee whaling, and that's true whether we're talking about North Atlantic right whales or North Pacific right whales or Southern right whales, all of them were decimated by whaling. And because they happen to be a species of whale that doesn't reproduce very frequently, they have a long time in between calves. Up to, more than 2 years, in some cases up to 6 years.
Is that how long the gestational period is, or between when they can get pregnant again?
In whales, it's like elephants. Gestation and depending on the species, it can be up to 14 months. So, and they're not very fecund. There's only usually one calf. And for whatever reason, bowhead whales are just not recovering from whaling. It's not like humpbacks, which were also whaled, but for some reason seem to be doing really well. And that, of course, depends on which ocean we're talking about. But so right whales have not recovered. And in the North Atlantic, they need to eat in exactly the same places where we live, which is to say cargo ships and cruise ships and fishing nets. We actually have to modify our own behavior to allow some space for North Atlantic right whales to survive. And there's only 450 of them left. We have a very good documentation of almost all those individuals because we started photo IDing them since about the 1990s. But the thing is, it's not really about the 450 individuals that are left. It's about the mothers, right? Like the future of that species really depends on how many active mothers there are in the population. Mm-hmm. And that number is probably somewhere around 100.
Crap.
So this is dire because last year, 17 North Atlantic right whales were killed, mostly by net entanglement. So it's clear what the major cause of mortality is for North Atlantic right whales. We need to modify our behavior if we think that there should be space for North Atlantic right whales in the future. Otherwise, it's not looking so good. And, the best case of what happens when we don't act is not just with the Yangtze River dolphin, but it's also with, which went extinct, we think, probably about 15, 20 years ago. And that it's clear that when you modify a whole river, it's the only river system that this species lives in, that's probably the reason for its extinction. All the changes that go along with building a dam to an animal that lives in that riverine habitat. It doesn't take, a genius to think about how that could affect a large mammal. The vaquita is probably going extinct before our eyes. This is a small porpoise that lives in the Gulf of California, and it only lives in the Gulf of California. It was only described in 1958. Before 1958, we had no idea the species existed, and it's been recognized since that time, and we knew that it was in danger 30 years ago, and scientists have been sounding the alarm. And when we looked last year, there were less than 30 of them alive, and there's probably far fewer. It may be extinct as we're talking right now because they tried something really crazy. I talk about this in the book. They tried ex situ conservation last year. So they had a team of veterinarians, of fisheries scientists, of marine biologists, of behavioral biologists, and they all got together and said, all right, let's try capturing and corralling the last of the vaquita and having them live in a sea pen so at least they have a fighting chance. Because the problem with vaquitas, they live in the same habitat that the totoaba live in. And totoaba swim bladders fetch enormous amounts of money on the Asian market for reasons that, are very suspicious. That they're medicinal. So that's a whole, that's...
And you said medicinal in quotes there. You couldn't see it, but there were air quotes there.
Yeah, yes. It's clear. So vaquita are going extinct or are extinct because they're bycatch. They're side effects of an illegal fishing industry in the Gulf of Mexico. And so this is how global geopolitics can affect a species, not directly through like whaling, where it's not literally a harpoon to that species that's targeted. It's a byproduct of the way that we live. And that's the big question, I think, for whales is what room is there for whales on planet Earth in the age of humans? I mean, and so it's not all dire. I mean, there are some like really sad stories, but there are stories of success. Humpback whales have been delisted since 1994 from the endangered species list. They've recovered from whaling. Gray whales seem to be able to move anywhere on the planet. And that's because gray whales have been spotted well outside the North Pacific. There have been gray whales that have been spotted in the Mediterranean and in the South Atlantic. So clearly, the barriers that exist for some species don't exist for others. And for species that have a broad ecological feeding envelope, so they can eat almost anything, they're really not going to be limited. Climate change may actually be a good thing for some species.
Yeah, but I don't think plastic is a good thing for any species in the ocean.
True. So we're just beginning to grapple with the enormity of microplastics.
Yeah.
I mean, that is something, it's really good to see all this news attention in the last year because this is a big, big problem. And, it's going to be a big problem when people discover that the salmon that they buy at Trader Joe's may or may not have microplastics in it.
Yeah.
I mean, this is how pervasive the problem might be. And we don't actually recognize that because we kind of think of the oceans as out of sight, out of mind. But the fact is that we live on planet Earth on planet ocean, right?
Yeah.
So the oceans are actually kind of a big deal. And most of the human species relies on animal protein from the oceans. It's a not insignificant number of humans who rely on animal protein from the oceans every day. So
sure.
This is a big problem. And, it's as much of a problem for whales as it's going to be for us.
Well, I'm not depressed because,
Good.
as you said, there are some really, really, it's not all bad news. There's some whales that have been doing really, really well. But of course, we can't keep this out of sight, out of mind. The ocean is not the away, and I do think that coastal communities have been more aware of this for longer. And it's good to see that a lot of people across the globe are becoming more aware of the fact that you don't want to buy a face scrub that has tiny plastics in it. You don't want to use single-use plastic bags, single-use water bottles.
Straws.
I think legislation, straws, terrible. Legislation's going to have to catch up with this. It cannot just be a consumer choice. But the nice thing is we're starting to see like massive changes. The question is really like, are we past a point of no return? I guess we'll just have to wait and see.
Yeah, that's a different question depending on, what you're looking at. And I think, tipping points definitely exist. The question is not whether they exist, but how soon do they happen and how quickly do they happen? So,
and they're different, like you said, for different ecologies. They're different for different forms of pollution, whether we're talking about acidification, whether we're talking about plastic, whether we're talking about warming or sea level rise, all those things are different and they all interplay with one another.
Right. It's super easy to be doom and gloom about the fate of all of us on this planet. But that's not really a super constructive way to be when you acknowledge that there are things I have to do in my life and I can exert some choice over that. Mm-hmm. And I think that's those kinds of answers quickly are not just answers for scientists to have, but for everybody to have. But no matter who you are, the data that we need to know about that falls into the realm of science. And so we do actually want to know what scientists say and what scientists think about all these problems. And that's not going to go away. That's not a matter of political preference or, convenience. So.
Absolutely. So along those same lines, Nick, I end every episode by asking my guests the same two questions. And we may have already kind of answered them, but I would love to just get a clean response from you about, and they're pretty big picture questions, but I try to end with the more positive one so we can end on a positive note.
Sure.
So I want you to think about the future. And of course, this can be in your personal life. It can be the future of the planet, the future of the universe. I assume, but I could be wrong, that you're going to be thinking about it through the lens of your work as a paleontologist, specifically focusing on whales. When you think about the future, the first question is, what is the thing that does keep you up the most at night? What are these questions that seem like, big difficulties, big problems that need to be solved that, sometimes you may feel discouraged or you may feel a bit pessimistic about. But on the flip side of that, what are you, generally optimistic about, hopeful about? When you think about the future? What are the things that you're like, yeah, it's going to be okay. We're doing great.
So the things that keep me up at night are probably not the things that keep most people up at night. And that is to say that, my day job is being a museum scientist. And so I think about a lot of opportunities that we have to document the world that slip right between our fingers, that we miss the chance to know about something. And that is true whether it's a fossil that's eroding out of a cliff or a species that's on the brink of extinction. So I'm worried about those opportunities that slip between our fingers. And so that's what keeps me up at night, is whether I've done enough to capture enough information about a locality that becomes bulldozed and no longer accessible, or if we missed an opportunity to collect a carcass that rots away and that's all we're ever going to get for the knowledge about a species. It's those kinds of opportunities that keep me up at night. But there's a lot of things to be bummed out about, to be depressed about in the world. But that is not a constructive thing when you realize the number of tasks that can be done, not just you individually, but by working together as a team. And that can be, I think about that with my research group. I think about that with my ability to communicate and tell stories about how we do science. So I'm actually very optimistic. There are so many stories to be optimistic about. The Smithsonian has a whole initiative about ocean optimism, about Earth optimism, really. It's a hashtag. You can follow it, Earth optimism. But
nice.
So I think the point of that is that doom and gloom is easy, but you wouldn't know that there are so many reasons to be optimistic that can be local scale success stories. And the scale of what's transpiring on the planet is at scales that are almost too hard to really grapple with as a whole. But that's not really the way that we should be thinking about it. We should be thinking about it at the local scale, about what's happening within the realm of something that I can handle. So that's kind of why I'm optimistic. I think we're going to figure it out. It doesn't mean that the world's not going to change, but I think that we're adaptable. We have adapted to challenges in the past. Some of my best friends are humans, so I'm rooting for Team Human.
Well, Nick, gosh, this was such a fun chat. I learned so much about whales, both past and present. And I know that my listeners did too. So I just have to thank you so much for joining me again. Yeah. And everybody, check out the book. What is the day that it goes on sale? Oh, June 26th, 2018. The book is Spying on Whales, the Past, Present, and Future of Earth's Most Awesome Creatures. It is available as of June 26, 2018. What a joy to have you on the show and share all of this knowledge with us.
Absolutely. You're so welcome. Thanks so much.
Of course. And everybody listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.